So here's the solution video I promised you for exam number 2. And you should know there were actually 2 versions of the exam. I'm only going to do one of them. This is the version that the 8 o'clock class took. There were only, I think, trivial differences. So if you were in the noon or 1 o'clock section, you notice a few of the problems are slightly different. And maybe I'll talk about some of those differences. So on question number 1, we're finding 4 derivatives. I'm not going to do part A. I think everybody got it right, not surprisingly. For part B, we have a product. We have the function x times the function e to the minus 2x. Therefore, the product rule is called for. And so the derivative g prime, the first function x, times the derivative of the second one, well, that's e to the minus 2x, times the derivative of the inside, which is negative 2. E to the minus 2x as a composition, so we use the chain rule there. And then we have the derivative of the first function, that's just 1, times e to the minus 2x. Okay, there's the derivative. I didn't ask you to simplify it. A lot of you did. You didn't need to. If you do, see if I can squeeze it in here. Maybe I can make my pencil a little bit finer. Yeah. So if you simplify it, then you can factor the e to the minus 2x out. And you get 1 minus 2x. All right, on part C, we have just a composition. The inside function is the inverse tangent. I wrote it as arctan so that there hopefully be no confusion. And so the square root function is the outside function, so h prime of x. The derivative of the square root we've memorized is 1 over 2 square roots. I'm going to write inverse tangent now like that. And then we multiply by the derivative of the inside, which is 0. The derivative of 1 is 0, plus the derivative of the arctangent, which is 1 over 1 plus x squared. Okay, and some people, you can combine it. You really can't simplify it much. So I'm going to leave it like that. And then we'll go to D. I did ask you to simplify this just because it simplifies super nicely. So we're using the quotient rule, 3 plus 2x, the bottom squared, times the bottom, up above we copy the bottom, and then we multiply by the derivative of the top, which is 4. We subtract the top, 4x minus 1, times the derivative of the bottom, which is 2. So look what happens here. We get a 8x right there, and then we get a minus 8x. So those just go away. So what survives? Well, I have this 3 times 4. I distribute the 4 out, and then we distribute the 2. So I get 12, and then I get, notice we have a minus 2. That makes plus. And we still have our denominator, 3 plus 2x squared. And of course, that's 14. Okay, and we're done with problem number 1. Like I mentioned in class, I was hoping that would get us pretty close to 32, a third of the exam points. It didn't quite work out that way. But, now's the time. If you struggled with any of these, it would be B, C, or D, certainly not part A. Then figure it out. I think it's simple. You just have to pay attention to detail, recognize, the rules that we have and how they apply. And we have a rule to cover every situation. Just like we do on question number 2 down here, we have an unknown function f. We know a little bit about it, not much. And we know how it relates to another function. So once again, on part A, we have a product, the square root of x times f, and so we're going to use the product rule. I'm going to not write my x's because it takes up too much space. So we'll take this first function times the derivative of the second, plus the derivative of the first. Again, that's 1 over 2 square roots times f of x. And then the problem asks us to calculate g prime to 4. So let's plug our 4 in. I'll just plug it in, and then we'll get the values Everywhere there's an x, plug in a 4. And then square root of 4 is 2. F prime to 4 is negative 5. Square root of 4 is still 2, so I get a 1/4 there. And then f of 4 is 3. And if you simplify that, you get negative 37/4. Actually, this right here would get you all of the points. You didn't have to do the arithmetic. Now in part B, a couple things going on here. There is a composition, so obviously we're going to use the chain rule. And this is the one problem where you had a log whose base was not e, just to give you a chance to show me that you know how to do it. So let's do it. The log is on the outside. The derivative of a log function is 1 over x times the natural log of the base, if it's not e. Okay, it's 1 over the inside function, which is f of x. So this is multiplied. And then the chain rule says multiplied by the derivative of the inside. So now we're going to plug in our 4, because that's what we're asked to calculate. And I get 1 over f of 4 right here is 3. So 3 log 5 times f prime times negative 5. Okay, there's our answer. It doesn't really simplify, so we'll just leave it. We could write it as a single fraction if it makes us feel better about it, 3 log 5. There you go, the first page.